Today we have a new exercise. Review exercise number 5. Question number. Choose the correct option. Question number 1. Choose the correct option. MCQs we are trying to solve. Let's say number first part. F of t is equal to 3t square plus 4t plus minus 5. Then f dash t is equal to option A 3t square minus 4t plus 5, option B 6t plus 4, C is equal to 12, and D is equal to 60 minus 5. And we are differentiating with respect to x. F of t is equal to 3t square plus 4t minus 5. Differentiating with respect to x, dy by dt. F of t is equal to dy dt with respect to t. We are differentiating plus 4t minus 5. So here 3 is constant, and we are using here power rule, exponent rule to t and 2 minus 1, and further derivative of t is equal to 1 plus 4, t derivative is 1 minus constant derivative is 0. Here we get 6t plus 4. Option B is here the correct option. Option F of t is equal to 3t square minus plus 4t minus 5. Then f double dash t is equal to 3t square minus 4t plus 5, and option B is 460 minus 4, and C is equal to 6, and D is equal to 60 plus 5. Using for the derivative, so dy by dt f of t and dy by dt f of 3t square plus 4t minus 5. So here 3 is constant we take from the outside, and here we are using power rule plus 4 into 1 minus 0. Here we get 6t plus 4. This is the first derivative. We change into this dy by dt. F of t is the first derivative. Again differentiating with respect to t. Again differentiating this function. So we write f double dash t is equal to 6, and 2t derivative is 1 plus 4 derivative 0 is equal to 6. Option C is here the correct option. Question f y is equal to e power mx, then dy power n and dx power n means n derivative. N time derivative, what is the result is equal to, so option A is n e power mx log of ex, and B m power n e power mx, and option C m e power mx, and D is equal to m e power n e power mx. Now here we are trying to solve this question. Y is equal to e power mx, and we are taking first derivative dy by dx. We are differentiating with respect to s dy by dx e power mx, so e power mx, and further derivative we take here the derivative of this function e power m power x mx. So we get here e mx into m, x derivative is 1 and 1 multiplied by m, so we get m e power mx, that is first derivative. Similarly, if we are finding the second derivative with respect to this function m and to mx and further derivative of this function, and here dy by dx we get mx and x derivative we get here 1 m into m power x into m multiplied by m we get here m square e power mx up to so on. If we continue the process n times means d power y and d power mxn is equal to m power n times, according step by step they are increasing 1 2 3 up to so on e power mx. So n time derivative m power n, so option B is the correct option. The fifth derivatives of f of x is equal to e power x is first e power x and b e power x plus 5 and c 5 e power x and d e power 5x. According to the is we know that the derivative of ex equal to ex, and here we are using the derivative of ex, first derivative ex is equal to ex, and further derivative of this function dy by dx x is equal to 1 e power x into 1 is equal to e power x. Similarly, if we are finding double dash x is equal to e power x, again further derivative of this function power of the x, so we get here ex into 1 is equal to ex. If we 4 times, 5 times if we are finding ex, and 4 times if we are finding the derivative of ex, and 5 times of this derivative of the fifth derivative is equal to e power x. So option A is here the correct option. F of x and its derivative at x is equal to x naught or f dash x naught, f double dash x naught, up to so on f n x naught n time derivative, then the nth order polynomial, then the nth order polynomial, f of x when we dash equal to option A is f of x plus f of x naught minus x f dash x plus x naught minus x whole power n in factorial f n x naught f of x, and for option B is f of x naught plus x naught minus x f dash x naught plus up to dash plus x minus x naught whole power n divided by n f of n x naught. And option C is f of x plus h plus x plus h f dash x minus h all power n factorial f f n x plus h f dash h f dash f dash h. And option D is f of x minus h plus x minus h f dash h plus x minus h whole power n divided by n factorial f dash h. F of x and its derivatives x naught x is equal to x naught are this one, then the polynomial f of x will be equal to, and this option, the correct option is B option is here. The correct option B is f of x naught x minus x naught f dash is, that is also called Taylor series. Taylor series or Taylor theorem. So this polynomial we are using in the Taylor series. Option B is here the correct option. To calculate the first 5 terms, to calculate the first 5 terms of Taylor series, for f of x is equal to ex exponential function, the maple command is used as Taylor e power 2x c Taylor e power 2x and x is equal to 0 and 5, d is equal to Taylor e power 2x, x is equal to 5. So, and computer, the maple command programming, if we are using the function exponential function is given. So the Taylor series, for the Taylor series, the Taylor is also given there. Their function and its values is always lies starting from the 0 and 5 interval are given. So option C is here the correct option, because the interval must, according to the command maple command, so Taylor function and their interval are used. X is equal to 0 and 5. Starting point must be 0 from the initial commands, otherwise it is not accept, and the command the equation of normal line at point x naught y naught is x minus x naught is equal to 1 over m y minus y naught, and option B is y minus y naught is equal to 1 over m x minus x naught. C is y minus y naught is equal to m x minus x naught, and option D is y minus y naught is equal to minus 1 over m x minus x naught. And the equation of for the normal line, the normal line is must be perpendicular to the tangent point, with the tangent point. So always we have know that the slope of for the line, if we are finding the slope y2 minus y1 divided by x2 minus x1. So y2 is equal to y minus, and y1 is equal to y naught, and x2 is equal to x minus, x1 is equal to x naught. So that is the value of x1 and y1 if we are replaced here. Now with the slope, if we are equation of the normal line y minus y naught minus 1 divided, because line is perpendicular minus 1, the lines are perpendicular, the line is tangent to that point line equation, so we can write m2 is equal to minus 1 divided by m1, or if we are finding m1 is equal to minus 1 over m2. In this situation we are put the values of the equation y minus y naught and minus 1 over m x minus x naught. So option D is here the correct option. D is the correct option. The angle of intersection, the angle of intersection of the two curves can be calculated. Of the two curves can be calculated by using the formula, by using formula number A part sine theta is equal to sine inverse 1 plus m1 m2 divided by 1 minus m1 m2, and part B theta is equal to tangent inverse 1 minus m1 m2 1 plus m1 m2, and option C is theta is equal to tangent inverse m1 minus m2 divided by 1 plus m1 m2, and D is equal to theta is equal to sine inverse m1 plus m2 1 minus m1 m2. Look here, therefore the angle of intersection between the two curves by using the formula theta tangent theta is equal to, so we are finding m1 minus m2 1 plus m1 m2. So theta is equal to tangent inverse, tangent is changed here, we write m1 minus m2 1 plus m1 m2. So option here C is the correct option according to this formula. X is differentiable on the open interval, on the open interval a over b the f of x is strictly increasing, then f of x is strictly increasing, f f f of x is greater than 0, and b f dash x is greater than 0, and f double dash x is greater than 0, and d is f double dash x is less than 0. X is differentiable on the open interval, so it means that the function f of x is exist if they are differentiating with respect to x, then the f of x is strictly increasing. So we are using the definition f dash first derivative of this function is 0, or dy by dx f of x is greater than 0. So this is the same, or we can write r. We got option is here. B is the correct option. F of x is not greater than, this function is not greater than, so this is wrong, and this function is greater than first derivative, and double derivative we are finding relative minimum. This condition is used for the relative minimum, and this is also related for maximum. So here the function is strictly increasing, we are finding, so the first derivative of f of x must be greater than 0. Thank you very much for watching. Please subscribe my channel and share this video with your friends and relatives also. Thanks again for watching.